Now, number 5 tells us to complete the square. Completing the square, I would put on your note sheet the steps to completing the square. And the first thing you do is you take the b value and you divide it by 2. And then you square it. And that gives you two things. It gives you the value which you want to add. It's called a magic number. It's my technical math word for it. It gives you the magic number. And that's the magic number you want to add to everything. So let's do that first. So we're going to take this quadratic function here, and we're going to take the b value, which happens to be 2. And the first thing we're going to do is we're going to divide it by 2. We get 1, and then we square it, which is 1 squared, and we get 1. So our magic number is 1. We are going to add 1 and immediately subtract it. Why do we do that? Because adding 1 and then subtracting 1 is not changing the value of anything, right? It's just like adding 0, which is doing nothing. Okay, and so you're like, if I'm doing nothing, why do I even do it? Well, the reason why is because if I take the plus 1 and I move it over here right next to the first two terms, it's very useful. So I'm going to put minus 3 minus 1 at the end, and then I have x squared plus 2x plus 1 at the beginning, and I'm going to group them with parentheses, and then what I'm going to do is I'm going to factor this. And if I factor this, I can see that I can get a square. A perfect square, right? It's going to end up being x plus 1 times x plus 1, right? And that is not a coincidence. The 1 here and the 1 here, where does it come from? It actually comes from this 1 here, okay? Before we square it, it gives us the 1 that is going to factor into here. So you don't really have to work hard to factor this. You already kind of know what it's going to be. It's going to be half of b. So I changed my x plus 1 times x plus 1 to x plus 1 squared, and then I'm going to take my minus 3 plus minus 1, minus 3 minus 1, and I'm going to combine them into a minus 4. And I just finished the process. I now have the same equation, except for now I have it in what I call vertex form. And the reason why it's called vertex form is because these two numbers here have to do with the vertex. If you remember, when we write the vertex, the quadratic in standard form, we write it like this. I'm sorry, not standard form, but vertex form. And you can see that I can look at the minus 4 here, and it's the same thing as plus k, right? And I can see that the minus h is the same as the plus 1. So that means that h is equal to negative 1, right? Because negative h is equal to plus 1, so positive h is equal to negative 1. And k is equal to negative 4, and I just found the vertex. It's negative 1 comma negative 4. Okay? All right. So that was completing the square. So completing the square, you take the b value, you divide by 2, and then you square it, and that's your magic number. And then you add and subtract the magic number. You add the magic number, and then you subtract the magic number. And the reason why you do that is because if you do that, you haven't really changed anything, but you have the magic number in there, which makes it very easy to factor. Okay? And then you factor it. Okay, so first you divide and then square the b, then you add and subtract the magic number, and then you factor. Okay. Number 6. A quadratic function has zeros at negative 2 and plus 1. Sketch a function that satisfies this condition, labeling important points on the function with coordinates. Assuming that the function has an a value of 1, convert the equation to standard form. Okay. A quadratic function has zeros at negative 2 and 1. So what that means is that if I was to draw a sketch of it, if I plotted the points negative 2 and positive 1, the parabola would actually go through those points. It has x-intercepts at those points. That's what it means to have a 0 at negative 2 and 1. The reason why they call it a 0 is because the parabola has a y value of 0 or a height of 0 at that point, thus a 0. Okay? So that's a sketch of a parabola with zeros at -2 and 1. Assuming that the function has an a value of 1, convert the equation to standard form. And you're like, I don't even have an equation. But you can make an equation because if you have a parabola that crosses the x-axis at -2 and 1, you know that it has this form. Okay, and the reason why you know that it has this form is, look at this equation. Look at this expression. If I put -2 in for x, this one here would become 0. This would become -3, but 0 times -3 is 0, right? It doesn't matter that the right side is -3 because the left side is 0. And once you have one of them being 0, then the whole thing is 0, okay? So if I put -2 in here, it's going to be 0. If I put +1 in there, the right side is going to be 0 also, right? The left side is going to be 3. So it's also going to be 0, okay? So I know that this expression, or this expression here is going to be 0 if I have x equals -2 or 1. Now I just need to put it into standard form with an a value of 1. Well, a we usually put in the front of everything, and if it's 1, we can just like erase it. And let's just expand this out so we can get to standard form. Remember, standard form looks like this: ax squared plus bx plus c. You should put that on your formula sheet too. Oops. Let's put this on the formula sheet. We'll say y equals that, standard form. Okay, and then we're going to do FOIL, and we're going to expand this. So we get x squared as the first, we get -2 as the last, and then our middle terms we get plus 2x and minus 1x. Combine these two, we get 1x for the middle term. Okay, and set that equal to y. And so this is our function in standard form. Number 7. The function below describes the height of a soccer ball after it is kicked when t is in the time in seconds. How many seconds after being kicked does it reach its maximum height? What is the maximum height reached? Okay, so remember that if you kick a ball, it kind of looks like an upside down parabola, right? And the way you're going to figure out when the moment that it reaches the maximum height is that you know that the vertex is located at the axis of symmetry. Here we can use standard form, which is ax squared plus bx, okay, plus c, to figure out what are the b and a values we should put in the axis of symmetry to figure out at what moment the thing is at the maximum height. So looking at this, I can see that -5 is at a, and 20 is b, right? Okay. So I'm going to say x equals, or t equals, right? -b all over 2a, 2 times -5. So that will give me -20 divided by -10, which is equal to 2. So the answer is, how many seconds after being kicked does it reach its maximum height? 2. What is the maximum height reached? Now I could find the y-coordinate of the value at t equals 2 seconds by substituting in t equals 2. So I'm going to have -5 times 2 squared plus 20 times 2. And that'll give me -5 times 4 plus 40, which is equal to 40 minus 20, which is 20. Okay? All right. And let's move on to page 4. Page 4. Find the results of the subtraction below. The only trick to doing a subtraction is to make sure you line up all the terms with the same degree. And what's tricky is sometimes we get one like this. Look, there's no x squared term. There's no x squared term. So it's harder to line up. We need to leave a space for the x squared term, or the x squared term, because we don't have one. So we'll just leave a space there. And then we'll put -2x plus 5. And then we're going to subtract this other expression here, which has a 3x squared. This one does have an x squared term, so it's a good thing we reserved the space here. Plus x minus 1. Remember, this plus x is actually plus 1x, okay? Now I'm going to do the subtraction. When you do the subtraction, make sure, since there's a subtraction in the parentheses, we have to like multiply the negative times every single one of these terms inside. So it's actually negative 3x squared, positive 2x squared, negative 1x, and positive 1. So now let's do the subtraction. 4 minus 3 is 1x. I'm sorry, this is cubed, right? Sorry. 1x cubed. And here we have 0 plus 2x squared, so it's just 2x squared. We have negative 2 minus 1, so it's negative 3x. And then we have plus 5 plus 1, which is plus 6. Okay, so that is the result of our addition. So on your note sheet, you might want to say that you need to line up the terms in your subtraction and addition. Number 9, find the result of the multiplication below using lattice multiplication or otherwise. I like to use lattice multiplication because even though it might seem like, oh, I'm too smart to use lattice multiplication, it's much easier to do things correctly and organized. Okay, so you write it out like that. Do you notice how there's no x squared term here? Since there's no x squared term, you need to put a 0 in for the x squared term. Otherwise, it doesn't line up. Okay? Then I just multiply all these terms times these terms. So 2x cubed times 2x is equal to 4x to the 4th. 2x cubed times negative 1 is negative 2x cubed. 0 times 2x is 0. 0 times negative 1 is 0. Negative 3x times 2x is equal to negative 6x squared. Negative 3x times negative 1 is positive 3x. And 2 times 2x is 4x. And 2 times negative 1 is negative 2. Now I'm going to do the addition part. And so, for example, 4x squared, 4x to the 4th plus nothing is 4x to the 4th. Negative 2x cubed plus 0 is just negative 2x cubed. 0 minus 6x squared is minus 6x squared. 3x plus 4x is 7x. And negative 2 plus nothing is negative 2. So my answer is 4x to the 4th minus 2x cubed minus 6x squared plus 7x minus 2. So that is the result of the multiplication. You could do that with like a FOIL type of multiplication too. If you are organized and know what you're doing, go ahead. Write down Pascal's triangle for n equals 6 and hence expand the binomial expression below. Okay, so remember Pascal's triangle starts like that, and then you just start adding up neighboring numbers. So like here we have two ones and they add up to 2. And so on. So these would be 3, 3, 1. And you notice like the outside edges, you don't have a number next to it. So you just pretend that you're adding it to 0. Okay? 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Okay. So basically we're going to use this last line here, the n equals 6 line. The way we identify as n equals 6 is because it's got a 6 in the second number. So the way you do it is you just write out the numbers in the row and leave spaces in between. And then you say, okay, well, what's going to happen is each one of the terms is going to be made up of the A term, the B term multiplied together, and a coefficient. What's the coefficient? The coefficient comes from Pascal's triangle. Okay? And the A and the B term, they have a pattern where they have exponent on them. Okay? And for the core, all you need to remember is that you're going to have A for the X for the A term, and you're going to have 1 for the B term. Okay? And that's the only thing you need to do for core. If you do extension, then you need to be able to do other things for A and B, not just X and 1. Okay, so the way it's going to look is it's going to start from the big number, n equals 6, and it's going to go down. Okay, so the a value is going to be like that. And remember, x to the 0 is the same thing as 1, so we don't even write it. Okay, and then the 1 value, if your b value is 1, then it doesn't matter. You don't have to put 1 here every time because 1 times anything is just the other thing, so it doesn't matter about the 1. So basically, when you have x plus 1 in the binomial, the only thing you need to do is to put in the x term, and you descend the powers from the n value all the way to 0. And then the other thing you need are the coefficients. So that's the answer for this one. Okay? So maybe on your note sheet, you could build Pascal's triangle so that you already have it there. Okay? Kind of takes up space, and it's really easy to do, but all right, and so that was page 4, and that's the end of this video.